Okay. Okay, so yeah, let's talk about the quiz. So first off, I asked fill in the blanks to X out of a single pass. We keep going with the rest of the loop. What do you use? And then to X out of the loop completely, what do you use, right? So the first one is continue, and the second one is break. So you can kind of think of, there's three statements that are kind of related. You can kind of think of them as on a continuum. There's continue, which only breaks out of a single iteration of a loop. So if we have a 10-step loop, we're doing something 10 times, and we continue on the second pass, we still do 3 through 10, right? So that's all it does. It breaks out of something, but in a light way. So more powerful than that is break. So break completely stops a block of code. So if we break in a loop, that loop is done, completely done, right? But the rest of our code in that function continues. Or I shouldn't say continues because that confuses it, right? Keeps going, and we keep doing it. So the sort of third, like the next step up from that in a similar sort of related way is the return keyword, which completely exits out of a function. So any named function, as soon as we hit return, it's over. If the function we happen to be in is our main function, our entire program is over. Right? So it's kind of like continue, break, return. Similar concepts, but each one's stronger than the last. So in this case, we want to continue and then break. Okay, so 2, this is really just pretty straightforward. There's not a lot of theory here. It's just one of these is the correct syntax for making an int array, right? There's no deep rationale for that. It's just, this is one of the things you just have to memorize. So in this case, it's D. Int myArray, and then bracket 5 bracket to say how big it's going to be. So 3, this was kind of the meatiest one, I would say. So we've got int test array, and we set it directly to five elements, right? So we've got 1, 2, 3, 4, 5. And then I use cout to print the 10th index, right? So that probably should actually, so A is probably what should, B is probably what really should happen in a better world, right? Our compiler really should not let us do that. But that's pretty sophisticated, and it's probably going to be fine. It's going to compile fine, and then break on you when your code runs, right? Because remember that when we index into an array, all we're really saying is start at the first element, wherever that is in memory. And then in this case, what the number is really doing is it's saying, okay, so this happens to be an integer array. Okay. I know that an int is, let's say, 4 bytes. It's, we've seen that a couple times in class. But however many bytes it is, right? So I'm going to take that number of bytes times whatever index I've got, in this case 10, and that's how farther forward along I'm going to read in memory. So that's a really, really dangerous thing to do. Most of the time, what you'll get out of that is just a random-ish garbled thing, right? Because we'll get, because we're out past our array. We're way outside of the actual contents of our array. Because the array, so this first line, I know we talked about this in class, but I kind of want to really emphasize this, because reading from bad parts of memory is a really good way to get yourself into trouble in C++. C++ makes it really easy to do that, and that's one of the big ways in which C++ can be dangerous, is when you're dealing with memory and you're reading from maybe a bad spot, right? So, so when we made our test array, we cleared off however wide this thing is. In this case, we got an int, so it's 4 bytes. So we cleared off 20 bytes reserved for this thing called test array. Totally cool, right? But when we index into the 11th element, we're actually reading from way beyond 20 bytes. So whatever we're reading from, there's data there. Well, it might not be data, right? But there's bits there. And they're in some sort of state from whatever the last time was they got used for something meaningful, right? Because it's something you guys should all be aware of, sort of just for your own personal edification. You never actually delete anything on a computer. Just know that. All right? So you delete something, all that happens is that area of memory gets marked as OK for reuse. If you ever really need to get rid of stuff, you need to do something more than that. You need to do stuff like make sure you overwrite it with all zeros. Or, burn your disk or something. Anyway, so A is the correct answer here, right? So we get kind of a random thing. Now, to be really pedantic about it, there is a chance we could get 0, and there's a chance we could get 5. But that is a vanishingly small likelihood, right? So it could be the case that we read an int from some random section of memory. And I should be clear that it's not actually random, right? I'm using random just to emphasize that it's not really where we're supposed to be reading from. It's and we're doing a bad thing here, right? It's not actually random. It's completely deterministic. So it might be the case that we happen to pull up a 0, or we happen to pull up a 5, but not very likely at all, right? So A is the right answer there. And just to be clear, I'm saying it's kind of a random value. I absolutely do not recommend that you use that as a way to get randomness. Do not do that. Because there is a chance that you could read from a place in memory that doesn't exist. It could happen that the place we pull out for the start of our array is right at the end of available memory. And there's enough room for what we're declaring, so there might be 20 bytes from the end, but there's not any more than that. So we could actually read from an area of memory that's not even accessible. So do not use this as a trick. This is to be avoided at all costs, right? You do not read from areas of memory that you shouldn't be reading from. Okay? There are tricky things you can do for randomness, but they involve getting random streams. So it's like, I mentioned this when we talked about randomness, but like the current Chrome browser uses mouse movement and internet traffic. Because that's essentially a pretty good random thing. Your hand's lying on the mouse, you're probably moving it a little bit even when you're not doing anything. Or when you are doing something, you're probably moving it in an organic way at least. So that kind of stuff is good if you want to do that to get more randomness. But don't just take a random chunk of memory from somewhere. That's dangerous. Okay. Finally, last question, where I asked you guys what's the correct way to write a for loop that starts at 100, goes down to 0 by 5, right? So D we can just toss out, because you can absolutely use for loops in a lot of different ways, right? So there's absolutely nothing preventing you from counting down instead of up. So A is what we almost always, this kind of structure of starting your index at 0, testing it for less than something, and adding 1, that's about 95% of all the for loops I've ever written, at least. At least 95%. So that'll be almost everything you ever write, will be that, right? But there's nothing saying you have to do that, right? You have to have something that initializes, or you don't have to. That could be blank, but it almost never is. So you have an initialization, a conditional, and then something that happens at the end of the loop, right? So in this case, what I've asked you guys for is start at 100. So, I mean, already that pretty much just gives us C. But just for the sake of talking about it, we want to start at 100, we want to go down to 0, and we want to go by 5. So both B and C step by 5 each time, which is good. But B does it still counting up. So instead of plus plus to add 1, it's plus equals 5, which adds 5. So not exactly what we want in this case. What we want is minus equals 5 to go down by 5 each time. So the likelihood of actually needing to do that is honestly pretty slight. Because you could do it with this kind of a loop too. You could just say, count from 0 to 20 and take 100 minus 5 times I. Which honestly is kind of what I end up doing a lot of the time. But yeah. Questions? Cool. All right, so today's quiz. Okay, so what I want to start out talking about today is debugging. So first thing about debugging is that there's at least 2 ways that term gets used. So let's talk about what debugging actually means. So here's what debugging, the first example of debugging a program ever. So this is a page from Grace Hopper's journal where they found an actual moth in the computer. So This is back in like the 50s or 60s. Computers were these big things with vacuum tubes that warmed up nicely. So, and bugs would actually crawl in and die, right? And that would cause problems. So Grace Hopper actually found a moth and says, first actual case of bug being found. So that's at least supposedly where the term debugging comes from, right? So, and why we call problems in code bugs. So yeah, so debugging informally can just mean, you're just working on your code and finding out why it's not working, right? So that's totally fine. And that's a lot of times, depending on context, if somebody says they're debugging, that might be all that they mean by it. So, and generally what it requires is just kind of staying calm and being really methodical, right? So that's the general term. So what you often have to do is you have to get more information about what exactly is going on in your code. So even though programs are completely deterministic, and even though you might be the only person that wrote any of the code, I guarantee you, once things get to any sort of sufficient size, and you guys have probably already seen this, you get into situations where it's hard to know exactly what's happening, right? So how do you deal with that? Well, one way to deal with it that we've done a lot in class so far is you just print statements out, right? So any language you use will have some way to just print out some statements that are really just meant for the developer. So far, we're just doing all console applications, so it's a little muddled, right? We use cout both to actually do what we're doing in the example, and we use it to sort of like test things sometimes, right? But depending on what you're using, like if you're using JavaScript, there's console.log. If you're using Flash, or ActionScript, there's trace, right? There's always some sort of way to just spit out some text information, right? And that's a lot of what you do, right? That's sort of informal quote debugging. And that's great. That's totally great. It's very important. You'll want to do it a lot. But there's also this notion of a debugger. So now you don't have to use it all the time, but it's something you guys should all be aware of, and it can be a really valuable tool. So that's what I want to start today talking about, is the debugger, right? So the debugger is a tool that you use to debug your program, right? So what it does is it does a few things. So one of the things we haven't really talked about is every time we build something, right? So there's this little thing here that says debug or release. So what's going on is by default, we're building this as a debug version. Now what does that mean? Well, what it means is that it's got a lot of extra hooks embedded in it that make it run a little slower, but allow for certain things to happen, like the debugger. So when we first talked about Visual Studio, we talked a little bit about this concept of an IDE, right? An integrated development environment. So an IDE is a few things. It's generally a good text editor that's programmer friendly, meaning a few things. It's just plain text. It's got line numbers. Hopefully it's got syntax highlighting. And to be really cool, it's got a nice dark default look, right? Because that's mandatory now. It's just nicer on the eyes. So anyway, but in addition to the text editor, it has various programs. So for a language like C++, we got to have a compiler, right? We also have a linker, which we haven't really talked about much, at least, but because it hasn't been necessary really for what we've been doing. So, but a linker, I think I mentioned this in an earlier class, but just to go back to it for a second, you don't recompile every part of your code every time, right? So eventually, when you work on projects of a real size, you'll have a whole bunch of source files, only some of which will change every time you go to try something, right? So you'll be like heads down really, really deep in your inventory system, let's say, which doesn't mean anything about the combat system, right? So if you were recompiling the combat system every time you tweak the UI for the inventory system, which might be a very small change that you have to do a lot, maybe, that'd be a real hassle, right? So what the linker's there to do is to take various compiled assets and link them together, allowing us to only compile some things every time we compile, which is really good because it saves a lot of time. So that's another sort of subcomponent of an IDE, right? Another subcomponent is this thing called a debugger. So what a debugger does, it's kind of like it's kind of like, let's say that you've got a car and there's a problem with your car. Right? So one way to kind of try to figure out what's going on is you could drive the car, observe what happens. You could try various things, right? And you might. There's a lot of information you can get that way. But at some point, you're probably, if it's a hard problem, you're probably going to have to open up the hood, right? And you're going to want to watch what happens inside the hood of your car as it's running. So that's what the debugger does. You can kind of think of it as it's how we open the hood of a car while it's running. So we can peel back our program while it's running and see exactly what's going on. So yeah, that's basically the big idea of debugging, right? Or debugger. You set something called breakpoints, which means that it stops your code at a specific place. And then what happens from there is you can step along. So, what's going on, I mean, I'm not going to talk about this code just yet. We'll get to this later in class. But we've got a bunch of code here, right? So here's our int main, right? So we start here. And the computer is basically just going down the list, right? So it hits this line. It says, oh, init common words. That's a function. It jumps up to where I've got that defined. Some stuff happens. We come back here. It goes to this. So it's going down the list, basically, right? So what debugging lets us do is say, hey, hold on a second. Open up the hood. And then deliberately step through each individual line of code. Sometimes even less than that. Sometimes it's a part of a line of code. Like we'll see in a minute when we show it with a for loop. So that can be really useful. How much you rely on the debugger and how much you rely on just print statement kind of stuff is kind of up to you. I'll be honest with you guys, I tend not to use debuggers that much, but it's invaluable when you get really stuck. When you have a really weird set of behavior, you're going to want to be able to go to your debugger. So let's talk about that. So I'm going to make a new project. This is for later today. Empty project, and we'll just call this WK7. And I'll add my source file. Oh, and let me go ahead and get that team thing up. So it'll be really important once we actually get into the example for today, because I'll definitely want you guys to follow along. Okay, so estimating presentation. Okay, let's see what we got. We got M40. M40, 793, 964. 793, 964. Yeah, correct. Oh, the project can be anything. Yeah, it's just you want to make sure it's an empty project. You can also make a console project, but that adds some stuff that is just unnecessary. So I recommend keeping it simple and just making an empty project. So empty project and then a single source file. Okay. So I got my source file, nothing going on yet. So I'm just going to add some boilerplate stuff like we always do. Include IO stream using namespace standard. Int main return 0. And just to actually do something here, I'm going to say int a equals 2, int b equals 3, int result equals a plus b. Okay, so nothing much really going on here, right? Oh, and just to pause it in a sort of low rent kind of way, I'll just say int input and cn input. So not what we'd really want for anything substantial, but pauses, right? So I'll run that just to make sure I haven't made any typos. And everything's fine, right? Okay, so that's fine. Just real simple program, not much going on here, right? But what I want to show you guys is how debugging works, right? So if I run this now, it runs fine. But what I want to do is I want to set a breakpoint. And what that's going to let me do is step through and watch every single thing that the computer does. So it's easy to kind of drown yourself in information, but we'll come back to that in a minute. So first thing I'm going to do is set a breakpoint. So where do I want to set a breakpoint? Well, you wouldn't want to do this. You almost certainly wouldn't want to actually do this, but for the sake of this demonstration, I'm just going to set a breakpoint right at the start. Int main. I'm going to set a breakpoint there. So what I can do is there's a couple things I can do here. I can just hit F9. So F9 will toggle a breakpoint. Or I can go to debug, toggle breakpoint. So either way, we get this red dot. Right? So a breakpoint always exists in a specific place in your code. So it's tied to a given line of code. So we've got a gear icon here we can do some stuff with. We'll come back to that in a minute. But key thing is we've got a breakpoint. So let's try running our code now with a breakpoint and see what happens. So I'll go to debug. Or sorry, we'll just hit our F5. Okay, so what happened, right? So we saw something blink, right? And if you blinked, you could have missed it, right? So what's going on is our program is running, but focus has switched back to Visual Studio. So what we're doing right now is it's stopped here. So as soon as it hit that breakpoint, it stopped execution, and it's waiting for us. So what we can do is we can observe here and see what the state of things is. It's just like we just opened the hood of our car. Except it also has this nice sort of effect. This is where the metaphor breaks down a little bit. We've also frozen things in time. So it stops everything. You can kind of like freeze frame the whole system and see what's going on. So, and if we come down here, so everybody take a look at my screen, and you'll see there's autos. And what I want you guys to do is click over to the locals tab here, right? So, right, so we see that we've got some local variables, but they've got some kind of weird values, right? So what I'm going to do is I'm going to step through the code, right? So now that we're stopped, just being stopped isn't too helpful. We can see we've got some locals defined, but values are kind of weird. So what I'm going to do is I'm just going to hit, in this case, either F10 or F11. So if we go to debug, there's step into, step over, and step out. So all of those do pretty much the same thing in this case. The difference comes when we have functions that we're calling. So if we've got methods of a class or functions that we've defined that we're calling into, then step into and step over are different, right? And so we'll come back to that in a minute. But right now, either one of them, F10 or F11, is going to tell the the computer to take the next step in the program. So I'm going to hit F10, and now we're at this line, right? So what's happening is we're seeing where we're at. So A right now, if we look at locals, right, we see A, and we see a value of some weird number, right? And what's going on here is we've defined A, but we haven't actually set its value yet. So if I hit F10 again, now look what happened. A became 2. What's going on there is that kind of brings home the fact that declaring a variable is one thing, and assigning it a value is another, right? So even though you can combine them into one line, I had to hit it twice, right, to get A equal to 2, because we set up A, and then we set its value to 2. So so again, it's not necessarily the case that every step you take will consume an entire line of your code. You might have lines that do multiple things. So yeah, so I can just keep going through here, right? So I'll hit F10 again. We see B now has a value of 3, and I'll do it again. We see result now has a value of 5. Now it's waiting for user input, so F10 isn't going to do anything, right? It's going back to here. It's not stepping through my code automatically. It's requiring me to enter something. So now I'll enter something. We go back here, and now input has 23. Right, so now we see nice orderly values for all our variables. So the key thing that's going on here is there's sort of two important things to be aware of, right? One, I'm stepping through each little piece of functionality, right? So nothing happens until I hit a button. And when I hit that button, one very small little thing happens, like making a new variable or setting its value or something like that, right? So one specific action. So that's key. The other thing to note, and this is where it really gets useful, is you can see the value of your variables. So this is basically why you use a debugger. So you can crack open the hood, see exactly what's defined, see what its values are, and then step through and observe exactly when those values change. Because that's generally what goes on. If you get yourself into trouble, often what's going on is something is changing when you didn't mean for it to, or it's changing in a weird way, or it's assuming a value you didn't want it to assume ever. Right? So programming is a really weird craft, right? Because on the one hand, it's completely deterministic. These are big logical machines, right? But on the other hand, if you get a system of any scale, it's really easy to have a machine that's too complicated to hold in your head at once, right? So I guarantee, even on small projects, you will get unexpected behavior. Even after you've been doing this for 10 years and you're awesome at it, you dream in code, right? You will still get unexpected behavior just because of the nature of the beast, right? So, so that's the key thing. Right, so a couple other things to talk about with debugging, but that's the most important, is it lets you step through and directly observe your variables. And then to stop debugging, I can hit Shift F5. So, which is somewhere here. Debug, I think. There we go, stop debugging, right? Because debugging is running your code. It's just, stepping through slowly. That's basic debugging. Any questions on that? I know it's pretty dry, but I got to make sure you guys are armed with this. So when you leave this class and you get into some really hard to parse situation at 2 a.m., you know how to use your debugger, right? So let's talk a little bit more about what's going on here, right? So you can also let's make I'm going to toggle this off. And I'm going to make another function just to show you how that works, right? So I'm going to say int function 1, let's say. And I'll return, let's do this. I'm going to make, let's do this actually. Okay, so I have a really simple function, right? All it's doing is it's taking in 2 inputs, adding them, and then returning that result, right? I wrote it on 2 lines just to make the example for the sake of debugging a little clearer. It's not, I would write this as a 1-line function if I was doing it for real. Or maybe not even have a function because it's so simple, right? But okay, so now what I want to talk about is the difference between step into and step over. So let's do that. So again, I'm gonna give myself a breakpoint, basically right at the start. Oh, and let's do this. I'm gonna call the function. So I'm gonna say result equals function 1, and I'll pass in A and B. Okay, so let's start. Oh, I need a breakpoint. So I'll hit F9. So now we've got a breakpoint, once again, basically right at the start of our code. So I'll hit F5. Again, it blinks to the console for a split second, and then it brings us back to Visual Studio. So it's showing us that we're right here, right? It starts out just, so nothing so different just yet. But, so I'm going to hit F10, I think. I always forget. So step over and step into aren't going to be different just yet. So I'll step over. Step over, right? Well, step over, right? But there's nothing to step over, right? Because over and into are only meaningful if there's another level, right? So, think of Inception again, right? So it's like if we're going deeper, that's something where we have a choice. Do we go into that function with the debugger, or do we just assume that that function works? because that might be fine, right? We might be, this might be a really complex function. And the problem might really be here. We might be confident that the problem is here rather than inside here. So we don't necessarily want to step through this a whole lot, because that gets really tedious. So, I'm going to step over. So now I'm at the line where we're about to call our function. So I'll step over. And now notice it just went to CN, right? So with F10 or step over, I was here with the debugger, right? And then it jumped to there. So let's look at what happens when I hit F11 instead. So I'm going to stop debugging with Shift F5 and start over. So I'm going to start debugging again. So once again, it starts where the breakpoint, where we set the breakpoint. So again, you would almost never want to set the breakpoint right at the start of your code, because that's just going to drive you nuts to step through every. I mean, it might be good for small programs and just sort of for your own education to do that once or twice to see exactly what happens for every step. But in a real program, you're going to want to set this like right before the problem area, right? And just see what's going on with the things that aren't quite working the way they should. Okay, so now I'm going to hit F11, which is going to step into. So again, no difference yet, right? Because there's nothing to step into yet. So far it's just the same. Now, we're about to call a function. If I hit F11, notice where we went. So this little, I didn't really point it out maybe, but this little arrow is showing us where we're at. Right? So now the debugger is stepping into that function. So now we can observe what's going on inside function 1. So really, really useful, right? You want to make that choice of, do I want to go into that function or not? Because going into functions that you don't want to is going to basically make the debugger so annoying to use you'll never use it, because you'll be just sitting there on the F10 key constantly. And never going into functions is also going to make the debugger basically not useful, because you'll never be able to go into things you need to check out, right? So you want to manage how much information you're dealing with. Okay, so yeah, and from here it's kind of the same, right? So now that we're into the function, again, F10 and F11 don't really have any difference, because within this function, this is the only layer we've got. I've only got 2 layers here. I've got my main function, and I have this one other function. Right? And so at this point, it's all the same. Right? So I'll hit F10 or F11, doesn't matter. Just keep stepping. And we get to the end of function 1, and we jump back. Right? And now we can see that result now has a value, and input doesn't yet. Right? So this is another good example of what happens with memory. Right? So input, right? We've declared input. And look at its value. It's negative, what is that, 88 million, 85 million, whatever it is. 858 million. Yeah. Anyway, right? Some weird number. Because we've carved out a chunk of memory for input, but it already has data there, right? So we interpret random bits, or a semi-random chunk of memory, as an integer, and we get some weird result. So, okay. I know this is absolutely enthralling, right? But like I said, it will save you, I guarantee, at least occasionally. So, questions about that? Step into, step over. Yeah, or no. Mm-hmm.
What happens if that doesn't pop up? Because I haven't seen that really.
Oh yeah. Oh, that's strange. You sure? So this entire panel wasn't there?
It's like it was there, but it was
Huh?
not.
Were you maybe in autos or watch? Yeah. So I recommend, at least for now, just staying in locals. I think autos is the default, but locals will give you everything that's locally defined. Right? So that, and we should let me start this over, and we should see first and second show up there. So let me debug again, and so I'll step I'll use F11, so we're stepping into things. Notice what happened. So when I stepped into function 1, locals changed. Right? So now I have first result and second. So first and second are defined, because as soon as I hit that function, right? As soon as I call this with some values, I get values for first and second. So we see 2 and 3. But then result, which so far all we know is it's an integer. So we've carved out a chunk of memory once again for an integer, but it's some weird number, right? Because again, we're reading from just some part of memory. So yeah, and if I keep going, then we get now results has a value, and now watch what happens to locals when I flip back, right? So the next time I step, because we're at the end, we're about to hit a return function, statement. So I'm about to go back to wherever I was, and when I do that, locals is going to change. So everybody watch down here when I hit F10. Oh well, let's do it one more time. So now we're back in the main scope, and we see stuff defined in main. So debugging also gives you a little bit of hopefully a little bit better insight into scope and how memory works a little bit. So, okay, there's a couple more things I want to give you guys about debugging, and then we'll move on to something that I think you guys will enjoy. It's kind of fun. All right, so I'm gonna make a for loop. Okay, so nothing that earth-shattering here, right? Really simple for loop that's just going to output a number, right? So if we debug this, right? So let me make sure I'm not debugging. So if I start over again, right? So now I can step, right? And now what's going to happen is I'm going to be able to step through this entire loop, right? So now we see I is some random part of memory. Now we see I assumes 0. We get to the end of the for loop. We jump back up. Now we see I is 1, et cetera, right? And if we do alt tab over, we can see that we've output 0 and 1 so far. So when we normally run something like this, we just get everything all at once, right? Because the computer does it really fast. So now I'm seeing just 2 bits of output. So one thing that can be really helpful to do sometimes is, let's say I've got a problem with the very last step in this for loop, right? So if I suspected something was going wrong when I was 0, right, then that'd be pretty easy. I could use debugging kind of like I'm doing right now, and just when I hit, set the breakpoint to the for loop, so I could do something like this. So okay, so let's say that I'm just printing out problem, right? But let's say that I have some code that's doing something that somehow fails when it's 0, right? 0 somehow causes it to blow up. So what I'm gonna I don't know that yet, right? I'm using the debugger to find out exactly when things blow up. So I'll set the breakpoint to the for loop, the start of the for loop, and make sure I'm not debugging, right? So I'll start the debugger, and I'll go ahead and see if I can maybe get this up to, maybe if I do that. Okay, so if I do that, I should be able to see what's going on here. So I'll hit F10, right? So we go down, and problem, right? So now I see the problem, and I can examine what's going on. So I see that I is 0. Oh, okay, well, maybe that's inside, right? So that's all good. But let's say that I've got a much bigger loop, first off, and the problem isn't in the start of the loop, it's at the very end. So somehow I've got some code that's causing me trouble, with the last thing I process, somehow, right? That would be really annoying to use the debugger for if I did it this way, right? So I'm going to stop debugging. And let's say that the problem doesn't reside at 0. It resides at index 9, right? So last index of this for loop. Again, this is just a toy example, right? I'm just looking at the number directly and spitting out a problem, but let's just pretend like I've got some complicated code that's blowing up in some way, right? And I don't know that it's happening when it's not. So if I do this now, right, this gets really kind of annoying. And then I have to just sit here and hit F10 a whole lot, right? So if I do that, I get 0, 1, and then I can keep doing that, and eventually I'll see the problem. And when I see the problem, I can go back to Visual Studio. I can look at the current state of my variables and see what's going on, right? So what I really want to do is I don't want this to trigger every time. So there's an easy way we can make that a little helpful. So what I'm going to do is I'm going to click on my breakpoint. Whoops, I just got rid of the breakpoint. So I'm going to click on the gear, and there's a really cool thing we can do, and that we can add a condition. So there's a couple options here. I'm going to come back to conditional expression in a minute. Hit count is really useful. So just for the sake of showing you. So there's 3 options here, right? There's conditional expression, which I'll come back to. Lets us only make the breakpoint work for us if something is true or something is false, right? Very, very useful. There's hit count, which will only have the breakpoint trigger if we've hit it a certain number of times. And then there's filter, which don't worry about for now. That's kind of a little more exotic and has to do with if you've got multiple machines or multiple threads. So we're not going to get into threading in this class, but just for the sake of context, threading means you have more than one process happening at the same time, with a big asterisk, because it's not really necessarily the same time. It might actually be the same time if you have multiple processors. So if you have multiple processors, you can do one thing per processor, right? So maybe a little bit of backstory, but a couple classes ago we talked about a Turing machine, right? So every computer that you use is kind of like its own Turing machine. And any Turing machine can only do one thing at a time. So, but there's this other way of sort of approaching problems that can be really good of, paralyzing it, right? So you try to do multiple things at once. So rather than having, doing A, then B, then C, then D, you have multiple things going at once. It's kind of like if you've got 5 things you need done. Let's say you're running a company, you need 5 things done. You could have one person do those 5 things, right? Do the first, then the second, then the third, then the fourth, the fifth. Or you could have 5 people each do one thing. And which of those is going to finish faster? Assuming all your employees are the same, right? Obviously, it's going to be giving one task per person, right? And having 5 people work on a task each, right? So that's kind of how multi-threading works. If you do have multiple processors, you can actually have literal multi-threading. If you have one processor, what's happening is it's kind of simulated, in that a certain amount of time gets allocated for one problem, and then the processor jumps, works on another, and then another, and then another, and then sort of goes back to the first. So it's as if it's working on multiple things at once, but it isn't really. So anyway, threading's a big topic. It can let very complex things happen a lot faster, but we're not going to talk about it in this class because it's very much an advanced kind of thing. So that's what the filter is. It lets you kind of filter out stuff that's not in the main thread or not on the given machine. So don't worry about that for now. So hit count, though. So what I'm going to do now is I'm going to set this hit count to, let's say, 8. So let's do that. So now I'm going to try debugging again. Oh, I think I never stopped. So let me stop debugging. OK. I'll take hit count. OK. All right, so let's try that again. Yeah, that should only be... Well, that's strange. Okay, let's functions can equals. Okay, let's debug. Well, that's strange. That should be working. I'm not sure why it isn't. So working at home, I swear. Oh, I know what I'm doing wrong. I'm going to put it inside the for loop. I bet that's what was going on. So I'm going to say hit count. Whoops. Equals 5, let's say. OK, let's try that. There we go. OK. So my mistake. So what was going on is it needed to be inside the for loop. So we hit the for loop, and we hit outside the for loop, basically, right? So we only hit that once. And then within the for loop, so we hit the outer, outside of the for loop only one time. So checking that for hitting it 9 times doesn't work. Whereas if I put the breakpoint inside the for loop, then I can check it for hitting more than once, right? So what was going on a minute ago when it wasn't working was everything was fine. It's just that I was looking for something that was, I was saying break if you hit this 9 times, or 8 times rather, was something that was only ever happening once. So it executed just like a normal run of the code with no breakpoint set. So, okay, so now we've got, we're stopping, we've gone through part of our for loop, and now it just works like normal debugging. And I can see things work as intended, right? So that's one way to kind of let yourself jump into specific, just sort of skip sections of your code. Okay. Another thing that's really useful is the conditional expression, right? So a lot of the times what will happen, right? I guarantee you guys will experience these kinds of bugs. So you'll have some code that you think works, right? And you'll think to yourself, like, there's no way that my ammo count would ever go negative, right? I start at some value. I check it to see if you've got at least that many bullets before I let you fire any, right? But somehow, through some, obscure sequence of events, that number will go negative and wreak havoc with the rest of your code, right? So a lot of the times what you'll want to do is have a breakpoint that only happens if something is, less than some value or greater than some value, right? So let's say this. Oh, well, let's say it's a void, actually. Okay, so let's just pretend like this function is doing all the work to fire bullets in our game, right? So if you think about what it means to fire a bullet, right? I don't know what firing a negative number of bullets would mean, right? It would kind of mean like, essentially bullets are spawning themselves inside my ammo clip or something like that, right? Weird behavior that is probably not good for my game, right? Now, I might think that, everything I've thought through, every place this gets called is only ever giving it a 0 or greater number, right? But maybe I'm doing some math on some input, and I think because the way I've tested it so far, because I'm doing reasonable things, never ends up with a negative. But there's no guarantee that players will only do reasonable things, right? So I guarantee you this is a big part of the reason you need QA, right? When you're working on your own code, I guarantee you're going to be nice to your game. Actually being mean to your game is a real skill that you have to cultivate. You're also going to think in a logical way about it, right? So you're going to do things that are reasonable. You're going to, not deliberately run into the wall 10 times, right? You're just not going to do that. But sometimes deliberately running into the wall 10 times expose really weird bugs, right? So that's why you need a good QA department. And yeah. So we also want to practice kind of defensive coding practices, right? So one of the ways to do that is to not just leave it at, well, I thought through it, and every time I deal with firing bullets, I'm not doing anything that I can see how I would get a negative number. Okay? So let's say we've got something and weird results are happening. So what we might want to do, because it's related to firing bullets somehow, right? So let's say that we've got something that, we say fire, let's say int num to fire equals get bullets to fire. Just to kind of make this a little more of an example. And then I'll say fire bullets num to fire. And just because I have to actually implement that function. So get bullets to fire. So for now, I'll just return 3, let's say, right? So okay. So this is again a toy example, right? So I've got some logic that's telling me how many bullets am I going to fire. Right? Because maybe we've got this, just to flesh it out a little bit. Let's say we're making one of those like bullet hell shooters, and there's a whole range of add-ons you can get to your guns, right? So bullets to fire changes a lot over the course of the game. So I run that code, I get num to fire, and I pass it into my fire bullets, right? So that's all good. Usually it's going to be reasonable, right? So right now I'm just returning 3. But let's say that somehow this gets to be -1. Right? Now, I would never just set it to -1. But let's just say that inside this get bullets to fire function, there's some complex logic. And I wrote it at 2 a.m. and when I hadn't gotten any sleep, and there's a certain pathway through it that gives me a -1. Right? So very, very possible and likely that you guys will run into that. So I started observing weird behavior with the firing. Really strange things start happening. Like maybe it could even end up being something like the number of bullets ready to go. Maybe I'm storing that somewhere, and it's getting into integer overflow. Because every frame, I'm adding a ton of bullets, right? Because I'm saying this ends up being negative. I subtract that from your ready crop of bullets. So somehow your number of ready bullets is just growing and overflows, and who knows what happens, right? So what I could do is I could set a breakpoint here. So I'm going to set a breakpoint. And I don't want to do it every time, though, right? So what I want to do is I just want to check to see, because I might think to myself, well, what if this is getting a negative number, right? So could happen, right? Shouldn't happen, but it could happen. So what I'm going to do is I'm going to edit this. So I'm going to say conditions. So I'm going to have conditional expression, right? So we looked at hit count a minute ago. Now I'm going to have conditional expression is true. And what I'm going to say is bullet num less than 0. So what this is going to do is it's going to stop, it's going to freeze the whole program if bullet num is ever less than 0. And then what I can do from there is I can step through it. So this is one way for me to sort of check and see, is this ever getting to be negative? Is this what's going on? Yeah. Actually, I'm going to put this in a different place. It's a better example. So okay, the reason I did that is because we've got this function, get bullets to fire, and by the fact that it's a function, it's strongly implying that I'm actually doing some work there, right? Just spitting out a single number generally isn't something you use a function for. I'm doing that here for the sake of a short example, but I would probably have some actual logic going on here, right? So I just wanted to, this is a more appropriate place to set the breakpoint. Hey, Dick.
Why you change the location of -1 next to return to the...
No, good question, right? So what I'm doing here is this is a sort of a faked example, but what would really happen is in between, like, instead of just setting this to a number, I would probably be doing some math or some other logic, right? So what I want to kind of simulate here is, let's say that I've got a bunch of logic. So I'm just going to put a comment, but, you know, lots of logic to figure out how many bullets to fire. Okay. So, you know, we might do something like, it might be really complicated. Who knows? We might do something like, you know, this might be an online game, right? So we might actually be doing this at the start of a level, and we might be doing like a database call to say, like, okay, for this user with their current loadout and, you know, maybe microtransaction things that they bought from me, how many bullets do they get to fire each time they hit the button, right? So could be a lot of stuff, right? It's not in this case, and if it was just this, not only would I not have a breakpoint, I wouldn't even have a function for it. But if this was going to be complicated, if I had a game with a robust inventory system and maybe microtransactions and a whole lot of stuff, right, going on that determines how many bullets you get to fire, I would absolutely have it in a function. Maybe a sequence of functions. There might be more to it, right? So anyway, so what I'm going to do is here, after I've done a whole bunch of logic potentially, I'm going to set a breakpoint. So I'm going to set a breakpoint, and I'll say num2 fire less than 0. Okay? So, yeah. So I'll add that. So let's say that this ends up being, actually, I'll make it a little more of a, let's do this. Okay, so my lots of logic is going to be just setting the number, right? So I declare an int, I set the int, but again, I'd normally be looking stuff up. And then after I've done that, I'm going to set a breakpoint. So num2 fire less than 0. Okay, so if I run it now, nothing's going to happen. Or rather, the program is just going to run, right? Because we're going to try to fire bullets, right? We're going to first find out how many bullets we get to fire, which we're going to set up an integer. We're going to simulate doing a bunch of logic to figure out how many we should fire by just setting it to 3. We're going to hit this breakpoint, but not actually break, because 3 is, in fact, greater than 0. Then we return it, and we go to fire bullets, and everything's fine, right? So if I run this right now, we're just going to see fired 3 bullets. Or are they still debugging? Okay. I was still debugging, so that's... Okay, fired 3 bullets, right? Everything's fine. So everything just behaves as normal. But let's say that somehow, through some mysterious means, my logic goes bad on me. And this ends up being -1. So now if I debug it, it stops, right? So we see num to fire is -1, and we're stopped. So it stops execution and gives me an opportunity to dig into what exactly is going on with the code and you know, see how we're doing. So, and that almost certainly gives me some good potential insight into what's actually happening with my code, and puts me farther along in the process of actually solving things. Questions? Okay, cool. So let's see. It's probably puts us right at sort of the middle of the class. So so that's pretty much what I want to talk about with debugging. Let's take a break. We'll come back and we'll talk about some string stuff that I want to get to last week and we didn't have time for. And we'll make a chatbot. So we'll make a really simple chatbot. So just demo that for you real quick. Let's see. Oh, still debugging. All right. It's easy to forget that you're still debugging because it brings you back to the IDE. So let's go back to this. And I'll just run it real quick. So we get something that says, hello, how are you today? I'll say, fine, thanks. How's the weather where you are? Let's say it's raining. And we get, I had a cousin that was really into raining, right? So not the smartest chatbot, but a really simple chatbot that exploits one really simple trick. It's like a BuzzFeed article. One weird trick that gives you a chatbot. So anyway, so we'll talk through this. And in the process of doing that, we'll get to talk a little bit more about string manipulation in C++, which we haven't really talked too much about, but will occupy kind of a lot of your time. So, cool. Cool, guys. Let's take a break.